Okay, hey guys, so let me go ahead and share this iPad screen with you. So if you need a little bit additional help with the warm-up, want to see if I can give you the support that you need. So here is that chart from your books that you need to use when you're trying to identify all of the different polygons here. Okay, so identify as many as you can in the tessellating pattern on 218. Tessellating pattern just means this grid here. Let me switch. Okay, great. So I want to start out by identifying which of these shapes right off the bat are pretty similar to one another. So of course we have our three triangles here, isosceles, where this side and this side are the same length. But also what that means, actually, okay. What that means is this side corresponds with this angle, and this side corresponds with this angle. Okay, so if this side and this side are equivalent, then this angle and this angle are equivalent. So that's isosceles. Next, we have an equilateral triangle. What that means is this side, and this side are all equal to one another. And so also this angle, and this angle are all equal to one another. And a scalene triangle where all three sides have different lengths, and therefore all three sides, let me see if I can go, all three sides have different corresponding angles. And you can see this angle corresponds to this side, this angle to this side, and this angle to this side, okay? And a square we're pretty familiar with. I want to, first of all, so we're used to comparing squares and rectangles. We do this quite often. We know that they have equal or sides that are parallel, except rectangles have one side that's, or two sides that are longer than the other two sides. But today what I want to do is I actually want to compare a square, a rhombus, and a kite, because these three are pretty similar with one another. So you can see that with these three, all sides are the same length, and that's super important. Well, actually, I'm sorry, this one is not the same, but these two, all sides are the same length. Okay, and what's important about that is that they look pretty similar to one another, except a rhombus is like a square that's just kind of been squashed a little bit, and it kind of like tilted a little bit to the side. They both have parallel sides. This one's a little bit more particular though. Opposite angles are equal. Diagonals intersect at right angles. What that means is when I do this, that forms a right angle. Diagonals intersect at right angles, like that. And same thing here. So diagonals intersect at right angles. And for this one, each of these is a right angle, but we already knew that. Okay, and then the reason I want to compare these with a kite is because it's almost like it is kind of like a rhombus, but you see how with the rhombus, all four sides are equal? Here, two of these sides are equal, and it's like these other two got kind of stretched and pulled out a little bit further. So that's why I like comparing squares, a rhombus, and a kite. Okay, now from here, let's do some natural pairings. So square and rectangle are naturally just really similar to one another. All interior, let me see, all interior angles are right angles, just like our square. And opposite sides are the same length, okay? And a square is a type of rectangle. parallelogram, it's kind of like the rhombus for the rectangle, right? Where you kind of take this rectangle and you just kind of like put some pressure on the top and it kind of slants to the side. So opposing sides are equal to one another. And two pairs of parallel sides, opposite sides are equal. Yeah, of course. Okay, and the trapezium. A trapezium is similar to a parallelogram, except it doesn't meet all of the requirements. So here, for the parallelogram, we have this side is parallel to this side. So we'd mark that with these little symbols, like those arrows. Okay, so those are parallel. Also, with a parallelogram, this side is parallel to this side here. With a trapezium, you'll only have one set of parallel lines. We can't say that this side and this side run parallel to one another. So a trapezium has only one set of parallel sides. Okay, so now that we've gone over all of these, let's take a look at exercise 4.5. So let's tackle some of the easier ones right off the bat. When I look at this, I'm really familiar with certain types of shapes, like this one here, that's obviously a square. That's going to be super easy. Okay, that's a square. And then also, let's try and look for something that has equal sides, 4 sides that are all equivalent in length. So when I look at those, I see here, looks like this is the same as this, is this, is this. So this one looks kind of like this one's going to be almost like it's a square, but it's been kind of flattened like that. And that's our rhombus. When I keep looking, okay, so this one I see here and here, those sides are equal. This side and this side is equal. So I know that's a rectangle. Okay. And then let's look for that one that's like a rectangle, but just kind of like squashed to the side. It's like the whole thing has just been tilted. And if I were to go up and look at these, oh, right. One that's squashed and tilted, that's a parallelogram. So let's see if we can find one that's similar to that shape, and it looks like this one. Okay, looking at the others, I recognize this one. Something that I also like about this shape is it actually looks like its namesake. Okay, so it looks like a kite. That one's pretty easy to remember. I really like that one actually. Now when I'm looking at these, I don't know right off the bat what they look like. When I'm looking at this, it looks like this and this are parallel. It also kind of looks like this and this are parallel. So I'm going to call that a parallelogram. So now when I look at these, it looks like this and this are parallel, but this and this definitely are not. So that's we called them trapezoids when I was younger, but you're calling them something different. Trapezium, okay. So that's a trapezium. And then when I'm looking at this one, okay, that and that are parallel, but this and this definitely are not, so that's another trapezium. Okay, so this is your warm-up. And let me figure out how to stop this. Okay, all right, thanks guys.